The reason it's nonpolar is we simply have two equal vectors in opposite directions, so they cancel each other out. The net effect is that we have a non-zero dipole moment, or that we have a zero dipole moment in the CO2 molecule. In contrast, we can look at H2O. H2O actually has this bent shape, and again, we'll see very soon how to predict that H2O has a bent shape, that water is bent. And again, we do have dipole moments. We have bonds where there is a polar bond, and we should point our arrow toward the oxygen because electron density is being pulled from the hydrogen atoms to the oxygen. And again, we can cancel some of these vectors out, but we still have a net dipole moment that is going to be going up if we think about combining these two vectors here. So what we would say, which is what we know from everything we've always heard, which is that water is a polar molecule. So this is a great way to think about molecules in general. It's very easy to think about, if those vectors cancel each other out, or if they're additive when we're talking about just single bonds, so we have two atoms, or if we have just three atoms, as we do in these cases here. But it turns out a lot of the molecules we consider are actually much, much, much larger than just a couple of atoms. So we can't often think about canceling all the different vectors out. And in general, when we're talking about these really large molecules, whether they're large organic molecules or we're talking about proteins, which can have thousands of atoms in them, instead of adding up all those individual polar bonds, what we do is we talk about the number of polar groups that it will have in the molecule. So we can think about a protein, for example, as having a lot of different polar groups, or one that has not too many polar side groups. That's one way you hear people talking about proteins, and that has a lot to do with their solubility in water, and also about how the protein is going to fold. But let's look at a little bit of a less complicated example than a protein with thousands of different atoms. Let's instead consider a couple of vitamins here, which instead have a few dozen different atoms in them. Specifically, let's look at vitamin A and vitamin B9. Does anyone know another name for vitamin B9? No. I don't think I hear it. Does anyone say folic acid? It's also sometimes called vitamin M. It's one of the vitamin B9 vitamins. There's actually other forms of vitamin B9, but this is one of the big ones that you hear about. Hopefully you're all very familiar with folic acid because it's an important vitamin to take, especially if you're a woman, especially if there's any chance you ever might become pregnant in any kind of near future time by accident or on purpose. And the reason for this is because folic acid deficiency in pregnant women leads to neural tube defects in babies. And your brain develops very, very, very early in pregnancy, the brain of an embryo. So it turns out that a lot of women don't realize they're pregnant while the fetus's brain is developing. And if these women are not getting enough folic acid, you can end up with spina bifida, which is an absolutely devastating and very preventable disease, or other neural tube defects. So hopefully, if you're not familiar with folic acid, you'll become familiar at least within the next 10 or 15 years or so before you're thinking about, maybe on purpose, becoming pregnant at some time. Vitamin A, you've probably all heard about growing up, getting enough of your carrots so you can see at night. Vitamin A is important for eye health. But just looking at the structure of these two molecules, knowing what we know so far about general chemistry, we can already say a lot about how these are going to function in the body, or how they'll be treated in the body. And specifically, let's take a look at which of these two molecules has more polar bonds and see what that tells us. So take a look at your two structures and tell me which has, between folic acid and vitamin A, more polar groups within the vitamin. And this should go pretty quickly since you don't need to have an exact number. We're just looking and glancing and seeing which has more. So let's take 10 seconds on this. All right, great. So most of you said folic acid or vitamin B9. So let's switch back to our notes and take a look at why. So vitamin B9 has more polar bonds. It's very easy to see once I highlight that it's not even a close call at all. we have a bunch of different polar bonds in B9 versus just one in vitamin A. Remember, the CH bond we're not calling polar covalent because it only has an electronegativity difference of 0.4 between the two atoms.